Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 11. A solenoid S of radius 50 centimeter and 100 turns per unit length is aligned along the x-axis. So we can see that this is a solenoid and it is aligned along the x-axis. It is carrying a current of 10 amperes. A coil capital C of radius 10 centimeter is coaxially placed inside the solenoid such that it can rotate about its diameter directed along the y-axis. So this is the coil C and it is rotating along the y-axis about its diameter. The diagram is given to us, and if the coil has 50 turns and it revolves with an angular speed of pi radian per second, then we need to determine the EMF generated in the coil. So we can see that current I is passing through the solenoid and it will create a magnetic field, and these magnetic field lines will also pass through the coil, and when the coil rotates there will be a change in the flux associated with the coil, and that will lead to the creation of EMF. So first find out the magnetic field due to the solenoid. So magnetic field due to solenoid, it is given by B is equal to mu naught N I, where small n is number of turns per unit length. So we can write it mu naught N is number of turns in the solenoid per unit length, that are 100 turns per unit length. So it is 100, and I is the current in the solenoid, that is 10 ampere. So it will be equal to 1000 mu naught. That is the value of B. And this B is passing through this coil C as well. So we have placed this coil in a magnetic field B, and the flux associated with the coil is changing because it is rotating. So omega, the angular speed is pi radian per second. It is given to us. And number of turns in the coil, they are 50. Also, the radius R, it is given to us as 10 centimeter, that is equal to 10 to the power minus 1 meter. We have to find out the flux associated with the coil. So flux linked with the coil phi m, it is equal to number of turns times B vector dot area vector. So that will be equal to NBA cos theta. And this theta, we can express it in terms of the angular speed. So that will be equal to NBA cos omega t. We all know that omega, it is equal to theta by t. Rate of change of angular displacement is angular speed. Now, once we have got this phi m, we can calculate the EMF associated with the coil due to change of this phi m. So we know EMF induced in the coil E is minus d upon dt of phi m, rate of change of magnetic flux. That will be equal to minus d upon dt NBA cos omega t. N is a constant, B is constant, and A is also constant. So that can be taken out of the differentiation. And the differentiation of cos omega t is minus omega sin omega t. So we can write it as NBA d upon dt of cos omega t. And this minus was also there. And the differentiation of cos omega t, it is minus omega sin omega t. So we are left with NBA omega sin omega t. This is the EMF induced in this coil C. Now we have to use the value of N, B, A and omega in this equation in order to get the EMF. So N, it is equal to 50, and B, the value of magnetic field we have calculated as 1000 mu naught. So 1000 mu naught, and area of the coil, it can be calculated as pi r square. So the radius was 10 to the power minus 1. So area, it is equal to pi into r square, that will be equal to pi times 10 to the power minus 2 meter square. So we can write pi multiplied by 10 to the power minus 2, and omega, it is given to us as pi radian. So we can write pi for omega as well, and then sine omega t. When we solve it out, it will be equal to, this will be, this 0 will cancel out with this 10 to the power minus 2, and we are left with 5 multiplied by 100 multiplied by mu naught multiplied by pi multiplied by pi. So that will be equal to 500 mu naught pi square sine omega t. So this is the final answer that is required. We can also put the value of mu naught, but even if we write it like this, it is sufficient. So this is the final answer, that the EMF induced in the coil C, it will be equal to 500 mu naught pi square sine omega t. Thank you. Keep learning, keep practicing, keep excelling.